All right, welcome to the deep dive. Um, Today we're diving into something, well, I think pretty exciting. Scaling an app to 1 million users.
Huh.
It's a dream for any app developer, and we're using this super in-depth guide we found on architecting a short-form video platform. So think TikTok, but even better, right?
Yeah, exactly. It's a
Mhm.
challenge, scaling to that many users, especially for startups.
Yeah, for sure.
So this guide, it's really cool. It lays out like a step-by-step plan, a roadmap for how to actually evolve your app's architecture.
Mm.
So you're always ready, right, for that next growth spurt, no matter how big it gets.
Okay, so you said roadmap. I'm curious, like, where does this roadmap even start? Are we talking like a complex blueprint, 1 million moving parts, or, can we start simple?
You know, that's the beauty of this guide. It says, like, start simple. Even, you're aiming for massive growth. You start with, it's called a well-structured monolith, basically one single application. And this is really helpful for, well, smaller teams especially. It's easier to, manage,
Yeah.
to change things up
Yeah.
and just to, like, get it going quickly.
So, like, building a house, if it's just like a small family, you don't start with a mansion, right? You start with a cozy, well-designed cottage. But knowing you can expand later on, does that analogy work?
Yeah, I like that. It's like the key is we're not building, like, a messy monolith, right? It's all about modularity.
Mm-hmm.
Like,
Mm-hmm.
think of designing your code with different rooms, right? Different
Mm-hmm.
sections, like user management, video handling, feed generation.
Yeah, makes sense.
So it keeps things organized, but
Yeah.
it also makes it easy to separate those modules later, if you need to.
Oh, okay, I see.
Yeah.
So it's like, preventing those future headaches by just like having that separation from the start.
Yeah. Yeah, exactly. Future proofing.
Love it. Future proofing. Okay, speaking of the future, what tools do we need? Like, what does the guide recommend for the initial tech stack?
So the guide suggests starting, with familiar technologies, things that'll let you, like, move fast as a developer,
Mm-hmm.
especially in the early days.
Makes sense.
So, pick a language and a framework you're comfortable with, like Node.js or Java.
Okay.
And then for the database, a single PostgreSQL instance. That'll work really well.
Yeah.
And then for all those awesome videos you're going to have, cloud object storage like Amazon S3, and of course the CDN. So those videos actually load fast for all those users you're going to get.
Okay, yeah. Those are all names I've heard before, but I gotta admit, sometimes I get lost in the databases and CDNs and all that. Can you remind me, and more importantly, remind our listener why those choices are like so good for an app that's trying to get 2 million users?
Okay, so imagine a CDN, right?
Yeah.
Like a network of servers spread out all over the place. And they're all storing copies of your, like, static content. So your videos, images, style sheets. So if you have, a user in Australia who wants to watch a video, they don't have to wait for it to, like, travel all the way from, a server in Europe or wherever.
Yeah.
They get it from, like, the closest CDN server. So it makes the app feel super responsive, right?
Right.
Yeah.
So it's all about speed. Got to keep those users happy. What about the database? PostgreSQL. Why that one?
Oh, PostgreSQL, that's a workhorse. Like, it's a powerful and reliable database, relational database,
Yeah.
proven itself like a ton of times. And then as your user base grows, you can, add a caching layer. Use something like Redis.
Okay, I've heard of Redis.
Yeah. Redis is, think of it as like a super efficient pantry, right?
Mhm.
And it's stocked with, like, your app's most used ingredients.
That's
So,
all.
you don't have to cook from scratch every single time.
Okay.
So it reduces the load on the database and makes everything, like, so much faster.
I love that pantry analogy. It really like helps me picture how caching works. So, okay, we've got our basic tech stack. We're ready to like unleash our app on the world,
But
right?
hold on a sec.
Yeah.
Before you hit those massive user numbers,
Yeah.
the guide really stresses you got to know your app's baseline performance.
Yeah.
Like, how does it perform under pressure?
Okay, so we're giving our app like a stress test, right? Before we send it to boot camp, gotta find its limits before they become like a real world problem.
Precisely. So we can use tools like Gatling,
Mhm.
and it simulates, like, thousands of users all hitting your app at the same time.
Okay.
So it'll help you identify any bottlenecks,
Hmm.
performance issues
Yeah.
early on.
Got it.
And we'll want to test our vertical scaling. So basically, can we just, like, beef up our server to handle more traffic?
Right, right. So it's like those car commercials where they're like pushing the cars to the limit in all these like extreme conditions.
Yeah.
You want to know your app can handle the heat before it, before it hits the highway.
Yeah, exactly.
Okay, so we're making sure it can handle the traffic. But I imagine like another big concern when you have a million users is, keeping your app up and running. Like, how do we prevent those dreaded website down messages?
Right. So that's where architecting for high availability comes in.
Yeah.
So we want to minimize downtime, which, can be costly, especially with lots of users.
Hmm.
The guide we're looking at, it aims for like 99.9% uptime or better.
Wow, 99.9%. That sounds ambitious. How much downtime is that like actually?
That's just a few hours per year.
Wow.
Yeah. And it's totally achievable with with the right approach to your architecture.
Okay, I'm hooked. Tell me the secrets. How do we build an app that's like a superhero for reliability?
So one of the key principles here is stateless services.
Okay.
So basically your app servers, they don't like store user session data, locally. It's like
Yeah.
a restaurant with like multiple chefs, right?
Yeah.
You want each chef to be able to jump in and like prepare any dish
Uh-huh.
without needing like specific ingredients from one particular station.
Yeah, I see what you mean.
So it lets you. Add more servers as traffic grows. Your app can handle it no matter what.
So it's like having like a team of servers like ready to step in no matter what the order is.
Yeah.
Cool. What other techniques can we use for high availability?
Okay, so redundancy, that's like super crucial, right? So deploying your app across multiple availability zones or, even geographic regions,
Right.
it means like if one area experiences an outage,
Hmm.
maybe power outage, network issues, whatever, your app, it stays online.
So it's like a backup generator for your app. If the power goes out, the lights stay on.
Yeah, exactly.
Smart.
And then failover strategies. So let's say, your main database goes down, which would
Yeah.
be a nightmare, right? You need to have like replicas of your database ready to take over right away.
Mhm.
So minimizing that downtime.
It's like having an understudy ready to step in if, the lead actor can't go on. I like it. Okay, so we've covered a lot about like making things run smoothly, but how does our initial modular monolith, how does that fit in with all these like high availability strategies?
Remember those logical boundaries we talked about earlier?
Yeah.
They're crucial as your app scales because they let you transition to a microservices architecture if you need to.
Right, right. The those different modules, user management, video handling, all that. How does that like transition actually happen?
So as your app grows, some module,
Yeah.
they might get way more traffic than others, right? Imagine like your feed module just getting bombarded with requests. Well, like your user profile module, it's totally chill.
Okay.
So that might be a sign that it's time to, give that feed module its own resources,
Yeah.
turn it into what's called a microservice.
So it's like, giving that really busy module its own office so it can like focus.
Exactly.
That makes sense.
And there's other benefits too. Like if you have, one team working on the feed and another on like user profiles, they can work totally independently, right?
Yeah.
So development speeds up.
Yeah, that's a great point. It seems like this whole modular approach, it not only makes the app more scalable, but like it improves how the team works together.
Yeah, totally.
But, I have a question. At some point, won't a single database, even a good one like PostgreSQL, won't that become a bottleneck, as the app grows and grows?
That's a great question.
Yeah.
And you're right to think ahead because, as you hit those massive user numbers, relying on just one database, it can get risky. Like it's
Yeah.
putting all your eggs in one basket.
Okay.
So that brings us to moving away from a single database and, using multiple databases, which might sound complicated, but it's actually about making your app like more resilient, more adaptable.
Oh, okay. I like resilience. I like adaptability. But I gotta confess, multiple databases. That sounds a little intimidating. Why would we want to like make things more complex?
It's not about complexity, for the sake of it. It's about optimizing for different needs, right? So like different parts of your app, they might benefit from different kinds of databases. For example, user profiles. Those might be best in a document database.
Yeah.
Right. Very flexible. But video metadata, that might stay in like a relational store, like, PostgreSQL.
Okay, so it's like having different tools for different jobs. You wouldn't use a hammer to screw in a light bulb. But now I'm just like picturing this problem, right? If our data is in multiple databases, how do we make sure everything's consistent? Seems like things could get out of sync pretty fast.
You're right. And that brings us to a crucial concept for scaling applications.
Yeah.
Eventual consistency.
Eventual consistency. That sounds intriguing, but also a little scary. Can you explain what that means and why it's like so important when we're dealing with a million users?
Okay, so imagine, right, you're posting a photo on social media. With strict consistency, everyone would see that photo, like instantly, no matter where they are. Great in theory, but at a massive scale, it's super difficult and it can really slow things down.
Yeah, like trying to synchronize, a million clocks, make sure they're all
Yeah.
perfect. It would take forever.
Exactly. So eventual consistency, it's a bit more pragmatic, right? It's like saying, look, changes might take a little time, to get across the whole system, but eventually everything will be consistent.
Okay.
So it's a trade-off, right? It
Yeah.
prioritizes performance and resilience, but maybe there's a bit of like temporary inconsistency. Think about like a social media feed, right?
Mhm.
You might not see like your friend's latest post immediately,
Yeah.
but eventually it'll show up.
Okay, yeah. I'm starting to get the logic of eventual consistency, but how do we actually like implement that? How do those changes get communicated across the whole system?
So that's where message brokers come in, like Kafka or RabbitMQ. They act as like super efficient postal services,
Okay.
delivering those updates, right, across all those different services and databases. So eventually everything catches up.
So it's like a network of couriers, like delivering messages, making sure everyone eventually gets the memo.
Exactly.
Love it. Okay. What about those times when things just like go wrong? Even with, the best architecture, there's that inevitable like 1 minute of downtime that every app seems to experience. What strategies can we use to minimize that impact, keep our users happy?
Right, right. So one powerful technique is circuit breakers. They act like safety switches, in your electrical system.
Okay.
So if, one specific service starts having problems, the circuit breaker, it trips.
Hmm.
And it prevents like that issue from cascading and taking down other parts of your app.
So it's like containing a fire, right, to
Mhm.
one room instead of letting it spread throughout the whole house.
Exactly. And we can use something called bulkheading, which is like, having separate compartments in a ship. If one compartment floods, the others, they stay afloat. The ship doesn't sink.
Okay.
So in our app, this means isolating resources, okay? So if one area fails, it doesn't bring down the whole system.
Love these analogies. It's all about like containing those problems, preventing a total meltdown. What other strategies, for graceful damage control do we have?
So another approach is graceful degradation. So let's say, our feed service, it's having a rough time, right?
Yeah.
Instead of just like showing users an error message, we could show them like a cached version of their feed
Yeah.
or, some trending content. Keep them engaged while we, fix things in the background.
So it's like saying, hey, the kitchen's closed for a minute, but feel free to enjoy some bar snacks while you wait. It keeps things like flowing smoothly, even when there's, some stuff happening behind the scenes.
Yeah, exactly.
Okay. What else? What else? What other tricks do we have?
We can also switch some services into like a read-only mode.
Mm-hmm.
So users might not be able to post new stuff, but they can still like browse and read existing content.
Okay, that makes sense. It's all about, keeping users engaged, keeping them happy, even when things aren't, totally perfect behind the scenes.
Right.
But how do we even know, like, when things are starting to go wrong?
That's where continuous monitoring, testing, and improvement comes in. So observability tools, those give you like insights into how your app is doing,
Mhm.
alert you to potential bottlenecks or issues before they like become big problems. And then there's this concept of chaos engineering.
Chaos engineering. Okay, that sounds a little intense. We're talking about, like, intentionally breaking things.
In a controlled way, of
Mhm.
course. So it's about proactively, introducing failures just to test your system's resilience, make sure all those redundancy and failover things are actually working.
So like a fire drill for your app.
Ex-
We're setting off a little controlled alarm to make sure everyone knows what to do.
Awesome. Okay. This has been a fantastic overview of like those first steps in scaling to 1 million users, starting simple with the modular monolith, architecting for high availability, and even, embracing a little chaos along the way. I'm
Yeah.
feeling a lot more confident, actually.
That's great, but remember, we've only like scratched the surface. In the next part of our, deep dive, we're going to go into multi-region architectures. So how do we serve, a global audience super fast, super reliably? We'll also dig into more advanced caching strategies and how to actually evolve your app's architecture as it, grows and matures. Can't wait. Until then, listeners, stay tuned and keep those app dreams alive. All right, welcome back to the deep dive. So last time, remember we were talking about like those core ideas, starting simple with a modular monolith and then architecting for high availability. And we even talked about embracing, a little bit of chaos along the way. Fun stuff. But this time, we're going global because, as your app starts taking off, you've got users all over the world. Things get more exciting, but also more challenging.
Definitely. Yeah, so today we're diving into multi-region architectures. It's kind of like, think of it like this. You're placing your app's servers, your data, in different parts of the world. So you're like setting up shop in multiple countries
Right.
to be closer to all your customers.
Okay, yeah. It sounds like a lot. What's like driving this whole multi-region thing? Is it just about like being closer to users, or are there other reasons?
Yeah, so there are actually three main reasons why companies go multi-region. So first, you're right. It's about reducing latency. Big time. Imagine, a user in Australia
Mm.
trying to watch a video that's hosted on a server, like all the way in Europe. That data's got to travel a long way.
Yeah.
So you get delays, buffering. It's annoying, right? So we put servers closer to the users, and boom, much better experience.
Yeah, like it's the difference between, ordering takeout from a place down the street versus ordering from across town.
Yeah.
The closer it is, the faster the food gets there. And in the app world, speed is king, right?
Absolutely.
Yeah.
Users, they expect everything instantly now. If your app is slow, they're gone.
Yeah, makes sense. Okay, so what were those other two reasons? You said three.
Right, right. The second reason is regional failover. Think about what happens if, like, a natural disaster hits, or a huge outage takes out a data center in one region. Well, with a multi-region setup, you've got a backup, right? Traffic gets routed automatically to a healthy region. So your app, it stays online no matter what.
So it's like having like multiple power grids for your city. If one goes down, the others can keep things running. No blackout.
Exactly.
Got it.
And then third reason, regulatory requirements. And these are like more and more important these days. A lot of countries, they've got data residency laws.
Yeah.
Right? So they say where user data can be stored, where it can be processed.
Yeah.
So multi-region architecture lets you comply with all those laws, keep data within specific geographic areas, like EU data's got to stay in the EU, things like that.
So it's not just about like performance and reliability. It's also about like, following the rules. Playing by the book. Makes sense. Okay, so we get the why now. But how do we actually do this multi-region thing? Like, what are the approaches?
Okay, so for multi-region deployments, there are like two main patterns. So one common one is active-passive.
Okay.
So you've got your like primary region, right? That's where your whole app is running, your main stage. And then you have a secondary region, a warm standby. It's ready to take over just in case the primary one, fails.
So it's like an understudy, ready to step in if the lead actor gets sick.
Exactly.
Keeps the show running.
Yeah, the active-passive setup, it's relatively simple to get going, but it can be a little slower to fail over. And users who are like far from the primary region, they might see some, higher latency.
Right. So there's a trade-off like simplicity versus performance.
Yeah.
Got it. What's the other approach?
So the other one is active-active. This is where it gets really interesting. So you have multiple regions, and they're all actively serving traffic. And you have a global load balancer. He's like a traffic director, right? Sends users to the closest region. So lower latency and even more resilience.
Okay, so multiple stages with shows happening all the time. No matter what happens, the show goes on.
Exactly. But this approach, it needs like more careful coordination between the regions, especially for the databases and caches. You got to make sure the data is in sync, and any conflicts, you got to resolve those smoothly.
Speaking of caches, didn't we talk about those earlier? They're pretty important for like making things fast, right? How do CDNs and caching fit into this whole multi-region picture?
So CDNs are even more important in a multi-region world. Remember, they're caching all that static content, the videos, the images, at those edge locations all around the globe. So by using a CDN, you're dramatically reducing the load on your origin servers.
Yeah.
And you're making things faster for everyone, no matter where they are.
It's like having like distribution centers stocked with all your app stuff strategically placed, worldwide so users can get what they need quickly from somewhere close by.
Yeah, perfect analogy.
And as we scale, like really scale, caching becomes, it's not just like an extra thing, it's like essential. I want to dig into these like advanced caching techniques a bit more. What are some ways we can really like supercharge performance?
So we talked about edge caching at the CDNs, which is great for the static stuff. But for dynamic data, things that change a lot, like user profiles, trending topics, that kind of thing, we can use distributed in-memory caches, like Redis. deployed across multiple regions.
Okay, so we're putting those pantries, with the frequently used ingredients, we're putting those in different regions. So no matter where the user is, those common requests are super fast.
Yeah, exactly. And then there's the hybrid approach. We can use like replicas of our main database in each region
Mm-hmm.
and then combine those with caching layers. So writes go to the primary database,
Mm-hmm.
but reads, those are handled by the local replicas. So super low latency and really good performance.
We're getting strategic, making sure the right data is, available in the right place at the right time. It's like a network of kitchens all set up to serve diners quickly and efficiently.
I like that. A network of kitchens.
Okay, but with all this data spread out, how do we keep things consistent? Remember eventual consistency, changes, going through gradually. How does that work in this like multi-region setup? It seems like things could get, even more out of sync.
Yeah, it does get more complex, but the principles are the same. We've got a few different database replication models we can use, each with their own trade-offs.
Okay, give me the rundown. What are the options?
So one option, the classic, is master read replica. So single primary database for all the writes, and then multiple read replicas spread across the regions. It's simple, but can have higher write latency.
Okay, so it's like having like one head chef, they're responsible for updating the menu, and then copies of the menu get sent out to all the other kitchens. Works, but it's a little slow if there are like a ton of menu changes.
Yeah, that's a good way to put it. Another option is multi-master, so multiple databases in different regions, and they can all accept writes. Lower latency for writes, but you got to be careful with conflicts, right? You need ways to resolve those.
So like multiple head chefs in different kitchens,
Yeah.
all able to make changes to the menu, but they got to communicate really well, to keep things consistent.
Yeah, that's it. And then finally, we've got eventual consistency using event streams. So changes go through a log, like Kafka. Each region processes those events
Mm-hmm.
and then updates its own databases.
So like a network of couriers delivering those menu updates to each kitchen.
Precisely. So it's a trade-off, right? You get availability, lower latency, but you got to be okay with the idea that, for a little bit, data might be slightly out of sync.
Okay, yeah. It's all about trade-offs, right? So we've covered multi-region caching, data replication. We're serving users globally with like lightning speed and amazing reliability. What else do we need to think about as we keep scaling? Million users and beyond.
Well, with all those users, you get a ton of data, right? And that data, it's super valuable. You can use it for recommendations, for optimizing your resources, for making all sorts of decisions about your business. But you need the right data infrastructure to handle it all.
So it's not just about storing it. It's about making that data work for you.
Interesting. What are like the key pieces of a data infrastructure that's, built for scale?
First, you need a data lake. So this is a big storage place for all your raw data, usually in an object store like Amazon S3 or Google Cloud Storage. It's like a massive warehouse, right? You store everything there just in case you need it later.
Makes sense.
Yeah.
Just, case.
Yeah.
But sometimes you need insights like right away. How do we get that?
Yeah. So for that, you need real-time streaming and aggregation. So you can use technologies like Kafka or Pulsar to collect and process all that data as it's coming in. So you can monitor things, detect problems, react quickly.
So it's like having sensors all over your app, checking its vital signs.
Exactly.
Oh, cool.
And then for deeper analysis and, reporting, you need an OLAP database or a data warehouse. So something like Snowflake or BigQuery. These are built for like complex queries,
Yeah.
helping you understand user behavior trends, all that stuff. So it's like having like a team of data analysts crunching the numbers, giving you those insights.
Precisely.
Okay, so we're scaling up, our infrastructure is growing. We got to talk about, the elephant in the room. Cost? How do we not break the bank?
Yeah, so scaling responsibly is super important. The good news is cloud providers, they've got tools for this. Auto-scaling, on-demand resources. So you can scale your servers, your databases, your caches, up or down based on what you need at the moment. You only pay for what you use.
So it's like having a workforce that expands and contracts depending on how much work there is to do.
Exactly. And then there are spot instances. So you can bid on unused cloud capacity, get a discount. Great for non-critical stuff. And then for predictable workloads, you can get reserve capacity, save some money there.
It's all about being smart, finding the balance between power and cost. I imagine, though, there are other things we got to think about, As our app grows, we're handling more user data. What about security, compliance, all that?
Yeah, those are crucial. So operating globally, high I, You got to make sure you meet those data residency requirements,
Mm-hmm.
strong encryption, key management, access controls. You got to be handling that user data responsibly and following all the rules, all the regulations.
You want a fortress, right, around that user data.
Exactly.
Yeah.
And your observability tools, those need to level up too. So you need like global traces, global metrics to see how things are doing across all your regions. Clear service level objectives, those SLOs, to define your reliability goals. And you might even want to do chaos engineering, but like at global scale now.
Chaos engineering, global scale. We're getting serious.
You got to make sure your app can handle anything, right? Simulate those big failures. Make sure all your redundancy, your failover, it all works as planned.
I'm seeing a pattern here. It's all about like planning ahead, right? Being prepared, testing, testing, testing. Not just hoping for the best, but actually building a system that can handle, the worst. So, disaster recovery. What if, like, the unthinkable happens, we lose a bunch of data? Nightmare scenario.
Yeah, that's why those regular cross-region backups are so important. You got to make sure your crucial data, user info, metadata, all your configurations, it's all replicated, backed up in multiple regions. And have those automated processes so you can restore things, if you need to.
So it's like having like a super secure vault where you keep copies of all your most valuable stuff
Yeah.
just in case, just in case the main building burns down.
Exactly. And you should also run, regular disaster recovery drills, simulate different failures, see how long it takes you to recover, find any bottlenecks.
So it's not just about having a plan. It's about practicing it, making sure it actually works when you need it.
Yeah, exactly. Scaling to 1 million users and beyond, it's a journey. It's not like a destination. It takes careful planning, continuous learning, and, being ready to adapt to change things up.
We've covered a lot today.
Hmm.
Multi-region architectures, caching strategies, data infrastructure, disaster recovery. I'm starting to really get how complex this can be. But also, like, the incredible potential.
Yeah, it's definitely a lot, but it's also super exciting. And we're not done yet. Next time, we're going to look at moving from that modular monolith to a microservices architecture. We'll dig deeper into even more advanced caching and how to, really evolve your app as your product, grows up.
Can't wait. All right, listeners, until then, keep those app dreams alive. And remember, even the most complex systems, they all start with, a single line of code. Welcome back to the deep dive. So for the past couple episodes, we've been, laying the groundwork. We talked about modular monoliths, high availability, even went global with multi-region architectures. But now it's time for, a topic that always gets people talking, microservices.
Yeah, microservices are they're definitely a hot topic, but it's important to remember they're not like a magic solution. There's a great benefits for sure, but they come with their own challenges too.
Right. It's not like one size fits all.
Exactly. So the decision to actually go with microservices, it really depends on your app, your specific needs.
Makes sense. For our listener who might be, hearing this for the first time, can you break it down? Like, what are microservices and why is everyone, so excited about them?
Okay, so simplest way to put it, microservices are about taking a big application and breaking it down into like smaller independent services.
Mm-hmm.
And these services, you can develop them, deploy them, scale them all independently. It's like, think of the city, right? With different districts, each one responsible for like a specific function, transportation, energy, sanitation.
Yeah.
Each district can, kind of do its own thing. Yeah. But they all work together to make the city, run.
I like that. It's a good way to like picture it. These independent services all working together, to form a bigger system. But we started off talking about, the modular monolith, all those benefits. So at what point do we say, okay, time to break up the monolith, time to go for microservices?
That's the question, right? And there's no like easy answer. It depends on so many things, how fast your app's growing, your team, your tech needs. But there are some signs you can look for.
Okay, yeah.
Yeah.
What are those signs? Like, what should our listener be, watching out for?
So one big one is when you have a module inside your monolith,
Yeah.
and it's just getting way more traffic than everything else. It needs like its own scaling strategy.
Yeah.
Remember we talked about, the feed module getting hammered with requests.
Yeah.
If it gets to the point where it's like always pushing your resources to the limit, that's a sign that maybe it's time to give it its own space. Make it a microservice.
So it's like, you have one room in your house. It's always crowded while the others are empty. Maybe it's time to build an extension. Give that room some space.
Exactly. Another sign is when different modules, okay, is the different tech, or they have different, release schedules. Maybe one module, it loves a NoSQL database,
Yeah.
but another one, it needs a relational database, or some modules need updates way more often than others.
It's like, you have a band and some members need to practice at different times with
Yeah.
different instruments. Trying to keep everyone in sync all the time just wouldn't work.
Exactly. And another big reason to think about microservices is team autonomy. So as your team grows, breaking things down into these smaller independent services, it lets teams work more on their own,
Yeah.
fewer dependencies, faster development.
So we're giving teams like ownership,
Mm-hmm.
flexibility. They can focus on their part without, stepping on each other's toes.
Exactly.
Okay, but you mentioned earlier microservices, they have their challenges too.
Oh, yeah, for sure. It's a whole new level of complexity. You got to manage communication between all these services, make sure the data is consistent, monitor a system with so many moving parts.
It's like conducting an orchestra, right?
Right.
You got all these musicians playing different instruments and you got to make sure it all sounds good together.
Perfect analogy.
Yeah.
So the decision to go with microservices, it's not something you take lightly. You got to weigh the good and the bad.
Yeah.
It's about picking the right architecture for where your app is right now.
Okay. So let's say we've thought about it, weighed the pros and cons, and we've decided, yes, microservices are the way to go. What are some of the key things we got to consider as we build these services?
Okay, so like we talked about before, clear boundaries between those services, super important. Each microservice, it has one job to do. And that job, it should align with, what your business does, like creating specialized departments in a company.
So it's not just randomly breaking up the monolith. It's about thoughtfully designing these services.
Yeah.
Okay.
And then you got to think about how these services are going to talk to each other. RESTful APIs are common, for the synchronous stuff. But as you get more and more services, you might want to look at event-driven architectures. Use message brokers like Kafka. That's for asynchronous communication.
So we're picking the right communication channels. Sometimes a phone call works. Sometimes you need an email.
Yeah, exactly.
Makes sense.
And then, of course, data management. Ideally, each microservice has its own data store, so it can scale on its own, use whatever tech it needs. But this brings up, the whole data consistency challenge again.
Right, right. If each service has its own data, how do we make sure everything's in sync?
So eventual consistency, remember we talked about that for multi-region, it's so important here. We can also use other patterns like sagas. They help you orchestrate transactions across multiple services. Keep that data integrity.
Sagas. Okay, that's a new one. What are those?
Imagine, booking a flight and a hotel room, a saga. It would make sure that if the hotel booking fails, the flight booking gets canceled too. So you're not stuck with a flight to nowhere.
Right, right.
It's a way to manage those complex processes that involve multiple services.
I'm starting to realize how much coordination this all takes, All these independent services working together.
Yeah, and that's why observability is even more crucial with microservices. You need tools for tracing, logging, monitoring, so you can understand how those services are interacting.
Yeah.
And quickly find any performance issues or errors.
Like a control room, right? With
Yeah.
all the dashboards and alerts.
Yeah.
Making sure everything's healthy.
And we can't forget caching, which, like we said, is super important as you scale.
Right. We talked about edge caching at the CDNs, distributed caches. Is there anything else we can do with caching in a microservices world?
Yeah, so we can look at more granular caching, caching specific API responses or database queries at the individual service level. And there are tools like Varnish or Squid for content caching.
So we're getting even more targeted with our caching, making sure the right information is ready no matter where it's needed in the system.
And as you get deeper into caching, you got to think about cache invalidation, making sure things are consistent, that users aren't seeing old data.
Right. Got to keep those cache ingredients fresh. What about database replication with microservices?
So since each microservice has its own database, it can choose its own replication strategy. Some might use master slave, some might go with multi-masters.
So we're customizing it basically.
Yeah. And as we scale and we've got all these microservices, security becomes even more important. Strong authentication, authorization, secure communication. You got to follow all those data protection rules.
It's like building like a secure little ecosystem. Each microservice is its own fortress protecting its data.
Got it. Okay, this has been an amazing deep dive. We started with, modular monoliths. We went global with multi-region architectures. And now we've explored this whole world of microservices. I feel like I really understand what it takes to build and scale, a truly successful app. That's great to hear. And remember, technology, it never stops changing. There's always something new coming out. New ways to manage data, serverless computing, edge computing. The key is to stay curious, keep learning,
Oh,
and, be ready for whatever comes next.
embrace the change. I love that. It's a good reminder that like this is a journey. It never really ends.
Exactly.
Well, thank you so much for joining us for this deep dive. I hope you've, learned a lot, gotten some inspiration for your own app adventures.
It's been fun.
Until next time, keep those app dreams alive. And remember, even the most complex systems, they all start with that first line of code.